Good day, all of you. Welcome to our session. Welcome to our channel, Intelligible Tutorials. In this today's session, I want to describe about the important concept of the domain testing, that is nice and ugly domains. This is one of the important question that already came in so many number of examinations. The difference between nice domains and as well as the ugly domains like that. Okay, so we will see the differences between the nice domains and as well as the ugly domains. Okay, so what is a nice domain actually? What are the various properties of the nice domain? We are going to see. As we all of you discussed in our previous session, that is the meaning of a domain actually the set of the input variables, whatever we have defined for the programming for and for the testing. Okay, so domains are some set of the input variables what we are going to perform our testing. Okay, the range of the input variables that is described as the domain here. Okay, so domains are defined by the imperfect iterative process aimed to achieve the utmost satisfaction by the user, buyer, or client, whoever it is. Okay, so whatever domains we have implemented so far, those must not be incomplete or inconsistent. Those must be complete and as well as the consistent only. Okay, so whatever input value that is treated as the domain, that will be processed possibly forever. Okay, so whatever input domain we have taken, that can be processed forever, and this should not be complete and it should not be inconsistent, it should not be incomplete, and as well as it should not be inconsistent. Okay, so whatever inconsistent domains we are having or incomplete domains we are having, we make them as the consistent and as well as complete domains. Okay, so now we see what are the nice domains, what are the properties of the nice domains now. Okay, so some of the properties that are there for the nice domains are nothing but having linearity, next having completeness, totally systematic, consistent, being convex, and simply connected. There is no complexity at all. These are the properties of the nice domains. Okay, once again, having the linearity, completeness, systematic, consistency, convexity, and as well as simply connected. Now we see what are the properties of dirty domains or ugly domains. Okay, these ugly domains are also treated as the dirty domains or incomplete domains or inconsistent domains like that. So many number of the names that we can give. Okay, so being non-linearity, incomplete, non-systematic, inconsistent, non-convex, not simply connected. If at all it is not simply connected, it is complexly connected and having holes in between them. All these are the properties totally of the ugly domains. Okay, so next we see, so what are the other things relevant to the nice domains? Okay, so nice domains having these properties, having testing is also easy whenever we are having these kind of the properties like linear, linear, complete, consistent, systematic, then the process of the testing will be very easy, and the existence of the bugs are also very less, so we can say that the bug frequency is less in the nice domain than the ugly domain. This, whereas the ugly domains are higher prone to the errors. Okay, so next, nice two-dimensional domains. This is one good example of the nice two-dimensional domains. Let us see the two-dimensional domain here. It is showing it is completely nice and consistent. Whatever rows and columns are there, they are completely connected and consistently connected. All are equal. All are equally sided and equally angled. So these are the properties of the nice two-dimensional domains. Okay, so next we are talking about for each and every domain we are having boundaries now. So what are the boundaries? We are talking about linear and non-linear boundaries. Linearity is one of the property of the nice domains. Non-linearity is one of the property of the ugly domains. Okay, so nice domain boundaries are defined as by linear inequalities or equations. Okay, so those are does not having the linear inequalities or equations. The impact of testing stems from the fact that it takes only 2 points to determine a straight line and 3 points to determine a plane, and general n plus 1 point, see here, n plus 1 point to determine an n-dimensional hyperplane. Okay, so whenever we are having 2 points, simply it's a straight line in the equal boundary. Whenever it is having 3 points, we can define it's a plane. And whenever we have multiple number of the points, it is an n-dimensional structure we can define like this. Okay, so in practice, more than 99.9% all the boundary predicates are either linear or can be linearized by simple variable transformations. This is one of the more important and very good property of the nice domains. Okay, so if at all it is not linear, we can linearize it, okay, by simple variable transformations. And whatever two points will be there, we can connect them. So in a way to form a straight line, in a way to form a plane, and in a way to form a n-dimensional structure like that. So these are the linear equalities. Okay, there is no linear inequalities in the nice domains. And nice domain boundaries are also complete, and they span number of the space plus 2 minus infinity number of the dimension in all dimensions. Okay, so they are complete, and they span number space from plus to minus infinity in all dimensions. Okay, so this is the complete, like a linear line will be there, in between it is 0. Okay, so plus to minus, so these are the minus values, minus, this is minus 1, and this is minus 10, like that. Here also the plus 1, and here we are having the plus 10, like that. Okay, so these are span in with well, multiple number of the dimensions. Okay, so incomplete domains, how the incomplete domains can look like. Normally incomplete domains is one of the property of the ugly domains. The incomplete domains can look like this. These are the holes will be there in between the domains. Let us consider E is one domain, D is one domain, A is one domain. See, the holes are there. These are incomplete domains. Holes means there is no continuity, there is no completeness, and there is no consistency. Okay, whereas B and C are the exact domains. There are no holes in it. Whereas A is one of the incomplete domain, and E is one of the incomplete domain, and D is one of the perfect domain. There is no holes at all. Like that, you can categorize the incomplete boundaries. Okay, such boundaries can come about because the path that hypothetically corresponds to them is unachievable. So one of the property of the incomplete boundaries is path is unachievable, and inputs are constrained in such a way that such values can't exist. Whatever values we are going to define for such domains are not existing because of incompleteness. Okay, no, not availability. And because of compound predicates that define a single boundary, or redundant predicates convert such boundary values into null set. That means sometimes we may have the null values in between these values, okay, or the values does not exist. These are the various properties of incomplete boundaries. Okay, now what are the advantages of complete boundaries over incomplete boundaries? Now we are going to see. The advantage of complete boundaries is that one set of tests is needed to confirm the boundary, no matter how many domains it bounds. So testing is very easy. One set of the boundary is one set of the test is used to confirm it. So multiple times testing is not needed. If a boundary is chopped up and has holes in it, then we need multiple number of the tests. Okay, so if it is complete, multiple number of the tests are not required, and testing made very easy. Whereas the boundary is sharp and it is having the holes in it, we have to test for each and every domain, for each and every incomplete domain, and for each and every incomplete domain. So that's why it is always very easy to test the complete domains rather than incomplete domains. Okay, next we see the systematic boundaries. What are the systematic boundaries? Normally we are having f1 of x greater than or equal to k1, f1 of x greater than or equal to k2, or f1 of x greater than or equal to g of 1 comma c, f2 of x greater than or equal to g of 2 comma c. Like that, here some linearity is representing f1 of x k1, here k2, here up to ki values, and here 1 comma c, 2 comma c, up to I comma c. Some linearly alignment is representing the value. Assignment of the values are also systematic, linearly ordered. Such a kind of the boundaries are called as the systematic boundaries. Okay, these kind of the boundaries are called as the systematic boundaries. Okay, so what is a systematic boundary now? Systematic boundary means the boundary inequality is related by a simple functions like constant. Okay, very minor inequalities, those are also can be represented by a constant. The domain boundaries uv differ by only one constant only, see here. Okay, and as well as fy is the arbitrary linear function, x is the input vector here we are having, and as well as k and c are the constants here. K here one is the constant value, and c is one constant value which can represented. Okay, and g of ic is a decent function or I comma c such that k of I comma c, it's a function which can represent the and uncover the inequalities by having some constants like that. So systematic boundaries make the incomplete boundaries as complete boundaries by representing some constants. By using some set of the constants, they can make the incomplete boundaries to the complete boundaries. These are called as the systematic boundaries. Okay, so this is one example of the systematic boundaries. Now, what are the orthogonal boundaries? Two boundary sets U and V are said to be orthogonal if every inequality in V is perpendicular to every inequality of A. See, this is the way of the perpendicular U and V, this one. Okay. So, if two boundary sets